Okay, this is going to be a short look at some different differential equations of some note. So first one is Hermite's equation. And these are in the book. And this is used for a quantum mechanical harmonic oscillator. And so we have the second derivative of y with respect to x minus a function of x times the first derivative of y with respect to x plus y itself equals 0. And so notice this is a second order. Linear ordinary differential equation with an independent variable of x and a dependent variable of y. Okay. Second order, ordinary, linear, because y is not squared or any of its derivatives are squared. We'll look at Laplace's equation, which is used in potential theory. And so we have second derivative, the partial derivative of some function with respect to x plus the partial derivative of some function with respect to y is equal to 0. It's a second order partial differential equation. The dependent variable is u, and the independent variables are x and y. And we can look at chemical reaction rates. I'm sorry, I'm going to try to get that TV off in the background. And so chemical reaction rates have an equation that kind of looks at a K constant here. And so we can have the change in the chemical over time, concentration of the chemical over time is K, some constant minus the current chemical concentration, and 1 minus the current chemical concentration. K is a constant in this equation. And so this is a first order, because the highest derivative is 1, ordinary differential equation, first order, ODE. But notice if I multiply this through, x is going to be squared, and x is the dependent variable. And so this is nonlinear. And the independent variable is t, and the dependent variable is x. And so this is kind of how we classify differential equations. And there are different ways we can, different differential equations we can classify. And the classification will help us pull out some of the tools. The next thing I'm going to do is I'm going to look at some examples of differential equations and what we can see that comes out of them. Specifically going to look at population models and free fall. And then we'll look at what constitutes a solution.